As you know, we are dealing with preparation method of phenols. 5 preparation methods we have already done. This is last one. From benzene and oleum, we can prepare phenol. Mechanism again not involved in 12th class. It will be for JE, NEET and BSc. Let's check what reaction is. Then we will understand mechanism. That reaction is getting completed in 4 steps. First one, this is normal benzene, colorless liquid. H2S2O7 is the formula of oleum. How it is generated? When I will tell you mechanism, I will tell you. You have to heat them at this temperature. Firstly, a waxy white crystalline solid of benzene sulfonic acid will generate. This is benzene sulfonic acid. Benzene sulfonic acid. This is sulfonic group. Learn it. SO3H, sulfonic functional group. This is the first step. Secondly, you have to react it with, you have to mix it in base. Which base? Sodium hydroxide aqua. Aqua means sodium hydroxide pellets are dissolved in water. That solution you have to add in benzene sulfonic acid. So it is a acid, it is a base. A very common reaction we know. Acid will provide H positive, base is going to provide OH negative. They will combine to release out H2O. And at the place of this H, this Na positive will join there. This will generate. This is salt. Which salt it is? The name will be sodium benzene sulfonate. Sodium benzene sulfonate. Second reaction. Now this compound you have to react again with sodium hydroxide. But this sodium hydroxide will be little differ as compared to this one. It will be melted sodium hydroxide. Melted, or you can call it fused sodium hydroxide. At the temperature of 573 Kelvin, you have to add these two chemicals together. Sodium hydroxide, it is differ from this one. It is aqua and it is melted, which is also known as fused. In this condition, this will generate. This compound already we have discussed many a time. Here I am writing, so it will be visible. Sodium phenoxide. In a preparation method of phenol, many a time this compound was generated, sodium phenoxide. And when this sodium benzene sulfonate react with NaOH, for balancing 2 NaOH are required, sodium sulfite salt will release out and water molecules will release out. Sodium phenoxide will be converted to phenol. We know very easily we can convert it. Just add dilute HCl in it. Means hydrolysis we have to do. Hydrolysis means breaking bond with the help of H positive and OH negative. Dilute condition means lot of water will provide H positive, OH negative. Here O is carrying negative, sodium is carrying positive, between them ionic bond is there. H positive will attack on O and OH negative will attack on Na positive. So when they will attack, OH will generate here phenol. It's a phenol formula, and NaOH will release out, which is a base, will react with HCl. Little HCl particles are there, NaOH is there. So acid base reaction will happen, due to which it will convert itself to NaCl finally plus H2O. So 1, 2, 3 and 4. In total 4 steps, phenol will be generated by this method. Now up to 12th level, we just need to learn this reaction. There is no mechanism. Mechanism I will tell you, but we should have a trick also to learn such reactions. So let me give you little bit tricks. So oleum Oleum always providing SO3 gas, sulfur trioxide gas. And in sulfur trioxide gas, oxygen electronegativity is more as compared to sulfur. So sulfur is working as a positive particle. Positive particles are electrophiles, they want electron. Benzene ring is a best source of electron because it contains pi electrons. So this S will attack on benzene rings carbon. So this carbon which is carrying hydrogen there. So with the help of S you will make bond with this carbon, you can check. And hydrogen will be replaced, you need to join with SO3. In mechanism part I will tell you. So in this fashion, first reaction you can understand very easily. Second is much easier as compared to first one, only acid base reaction is there. H positive, OH negative, H2 will release out, Na positive will join on SO3 like this, sodium benzene sulfonate will generate. And this third step, let me tell you. Okay, fourth step is very easy, you can check. O negative, Na positive. In previous videos also I told you how to solve this. H positive is there, it will combine on O negative. OH negative will attack on Na positive, so OH and NaOH will generate. NaOH will further react with HCl, NaCl, H2O. So let's understand this third step. Let me give you a trick to learn it. Complete cramming is very, very difficult in organic chemistry. So little bit information can help you. Actually, this sodium benzene sulfonate is in this condition. So when you will react it with NaOH, so this Na positive, OH negative. So this Na positive is a positive particle, will attack on a negative particle, oxygen. So when oxygen will make bond with sodium, in this fashion you can understand, pi electrons will shift. Sulfur will break bond from carbon because it has lost electron, like this, in this fashion. So this whole part will generate as a ONA, and O. SO3, this Na2 SO3 salt, Na2 SO3. And because carbon has lost, so positive charge will develop. That positive particle will be attacked by OH negative. So here OH, but you know in balanced equation one more NaOH is given. So one more NaOH. As you know, phenol is acidic, H positive, OH negative. This is H positive, OH negative. They will combine to release out H2O and Na will join here on O. So finally we will get ONA. This one. This is not an exact mechanism. This is for 12th class students to learn this reaction. In this fashion they can learn it easily. So ONA will generate and you can check H2 is released out and Na2 SO3 is released out like this. After ONA you know what to do. It's hydrolysis you need to do. Now let's go for actual mechanism. The 12th class students can learn this reaction in this fashion. Very easily they can understand it. Divide that reaction in 4 parts. And one by one every step learn it, and little informations that are required I have already given in the video. Now let's go for the mechanism. Let's solve first reaction. If I talk about oleum, now what is this oleum? It is nothing but a mixture of sulfuric acid. It will be 100% concentrated sulfuric acid, 100% concentrated sulfuric acid. Sulfur trioxide gas will be dissolved in it. Sulfur trioxide gas dissolved in 100% sulfuric acid. This is known as oleum. You can check when they will combine. What formula we are getting? H2, S2, O7. This one. So oleum is nothing but a dissolved sulfur trioxide gas in sulfuric acid, and it will be 100% concentrated sulfuric acid. Now when you will heat oleum, so obviously what will happen? If I am heating oleum liquid, so what will happen? Sulfur dioxide gas will generate out. This is the formula of sulfur trioxide gas, SO3. Liquid oleum, when you will heat, obviously it will release out sulfur trioxide gas. In sulfur trioxide gas, you can check sulfur is making 6 covalent bond with oxygen, and oxygen are more electronegative than sulfur, as you know. So these 6 electrons are going toward oxygen. So this sulfur is carrying partial plus 6 charge. Partial plus 6 charge will make this sulfur highly electrophilic, means it have a power to attract electrons. So that's why this sulfur is working as a electrophile there. Now who can provide electrons to it? Benzene ring is waiting with its pi electron. So let's start. So in first reaction, this is the first reaction, the mechanism will be something like this. H2S2O7 means oleum on heating will give you H2SO4 and SO3 gas. This SO3 gas will attack on benzene ring in which pi electrons are present. Here hydrogens are there. I am writing them. This sulfur is partially 6 positively charged. Let's start. This require electrons. Who can provide electrons? Obviously benzene ring and carbons. So suppose I am attacking this carbon. This one. So obviously sulfur can make maximum 6 bonds. So if it is going toward carbon, so all these old bonds will break. And how they will break? Pi bond will break, because pi bonds are weak bonds. Both electrons will pass toward oxygen because oxygen is more electronegative than sulfur. So who will provide electron to this sulfur for bond formation? This carbon. This carbon. This carbon will shift these pi electrons toward itself and will use these pi electrons to make dative bond with sulfur. In this condition, what will happen? Now because this carbon is losing its electron, this electron is shifting to that side. So this carbon will carry a positive charge and a vacant orbital, this one. And this carbon, who is connected with hydrogen, will make dative bond with sulfur. Sulfur, 2 oxygens as it is, this oxygen as it is. But this oxygen who is getting extra electron of sulfur will make now single bond and will carry a -1 charge. With how many pair of electrons? Already it has 2 pairs. Third pair will generate like this. This one, O negative. So please check carefully, this will generate. Here double bond is there. If it is not visible, I am telling you, here double bond is there between oxygen. Double bond is there between oxygen. This oxygen, third oxygen, will have a now single bond with a negative charge. Now, is it a stable condition? No. Benzene ring has lost its aromatic character. So what it will do? The carbon who has made it unstable will regenerate its stability. How? Look, this carbon has made it unstable. So it will break bond from its hydrogen and will shift these electrons here again for the vacant orbital of this carbon. So vacant orbital, this pair will make double bond with each other. Single bond is already there. Next double bond will generate between them. So both can satisfy each other. So again double bond will generate here and vacant orbital of this carbon will get satisfaction. It's hydrogen as it is. Rest hydrogens I am not writing. This hydrogen. Now this hydrogen has lost its electron. So it will release out as H positive with a vacant orbital. This H positive have a vacant orbital. This oxygen is negatively charged, have a extra lone pair. So can they satisfy each other? Yes. So this H positive will attack on this oxygen. So we will get this one. Now this oxygen was carrying 3 lone pairs. Out of 3 lone pairs, 1 lone pair it will use to make bond with hydrogen, dative bond. So it will transfer its electron completely toward hydrogen, so its negative charge will finish, and hydrogen is getting 1 electron from oxygen side, so its positive charge will finish. And they will come in this situation, this one, balanced. Now no charge is there. This we call benzene sulfonic acid. This is benzene sulfonic acid. This is the mechanism of first step. And this process is also known as sulfonation, because we have added sulfonic group on a benzene ring. That's why this process is also known as sulfonation. Actually, this is available in 11th class also with mechanism. Now let's check what will happen with benzene sulfonic acid, mechanism of a second step. Very easy, not so new for you. Even a 10th class student can tell what will be the mechanism for it. In benzene sulfonic acid, as you know, oxygen is more electronegative than hydrogen. So these electrons, these shared electrons, are more toward oxygen side, because hydrogen is losing hold on its electrons, so it is highly positive. Means it is working as a acidic hydrogen. In this condition, if you are reacting it with sodium hydroxide aqua. In sodium hydroxide aqua, means sodium hydroxide when dissolved in water, it always break in two parts. Na positive, OH negative. In OH negative, who is carrying negative charge? This oxygen is carrying negative charge. OH negative, H positive, they are going to combine. What will release out? H2O. Now when bond between oxygen and hydrogen break, both electrons will shift toward oxygen, because oxygen is more electronegative. Because oxygen will carry one extra electron of hydrogen, so it will become minus charged. Complete -1 will come. Complete -1 will be satisfied by complete positive of sodium. So here sodium will attack on this oxygen, and we will get this one. Between sodium and oxygen, ionic bond will be there. Now this is the second step of the reaction. Sodium benzene sulfonate is generated as a salt. Water molecules are released out, salt is generated, sodium benzene sulfonate. Simple acid-base reaction. Let's go for the third step now. What will happen in third step? Now only third step is quite complicated. After that, fourth we know what is happening there. So let's understand third step. This benzene sulfonate, sodium benzene sulfonate, which is generated over here, it is going to react with NaOH fused. Fused means melted. And we are going to heat it. Obviously, you know that sodium hydroxide in melted form will have Na positive and OH negative in it. This one. Now listen, its actual mechanism. Initially, I have given you a trick to solve that reaction, but that is not actual mechanism. Now what is the actual mechanism? Actually, this carbon which is connected with sulfur, and you know sulfur is connected with oxygen, and oxygens are highly electronegative. So these oxygens are pulling electrons toward themselves, due to which sulfur is getting positive charge. In turn, sulfur is attracting electrons from carbon side, like this. So this carbon is getting positive charge. Due to very high positive charge on carbon, OH negative is attacking on this carbon, like this. This is the first step. Obviously, carbon cannot make 5 bonds. So first, its weak bond will break. Which is a weak bond? Obviously, pi bond. Pi electrons will be further shifted to this carbon, like this. This is the first attack. Due to which, please check what conditions are going to generate. And you can understand why pi electrons are pushed further, because OH is coming with the electrons. For bond formation, 2 electrons are required. OH already carrying these electrons. It is giving those electrons to carbon. Obviously, electronic repulsion will be there. Electrons are coming from here, electrons are here. So pi electrons will be further pushed. So here OH is, SO3 is also there as it is. No change in SO3. This one. But this carbon will be in trouble now. because it got extra electrons like this. This electron was of this carbon, now it is on this carbon, so this carbon is getting extra electrons, so -1 charge will be generated on it. Carboanion is generated. Now, is it a stable condition? No, obviously no. What will happen? Very easily we can understand these electrons will be shifted again like this, and now this bond will break and electrons will move toward sulfur. Reason, as already I told you, oxygens are connected here and these oxygens are highly electronegative, so they are pulling electrons toward themselves. That's why this carbon is already a positive carbon, due to which OH negative has attacked on it. But still this carbon is connected with this group and now oxygen is also increased, so it will become positive. This positive carbon will attract these negative extra electrons toward itself. So obviously this bond will break now. Sulfur and carbon bond, not oxygen carbon bond, because oxygen carbon bond is short and sulfur carbon bond is lengthy. Lengthy bonds are weak bond, and secondly, this sulfur is facing a problem of pulling of electron from oxygen, due to which in turn it is attracting electrons from carbon side and this bond is getting weaker. So this will happen. This bond will break and here this bond will generate. So finally you can check what will released out. Double bond will generate back here. At the place of SO3Na, OH will be there now. And what will release out? Because sulfur is getting electron like this, this was the initial condition, -1 like this. So what will happen? Sulfur with a negative charge, unstable condition, this oxygen will break bond from sulfur, because obviously if sulfur got negative charge, oxygens are more electronegative, so they will attract those electrons. Not directly, indirectly. This oxygen will break bond from sulfur and will shift these pi electrons toward itself, due to which you can check what will happen. From sulfur, negative charge will finish, because you can check 1 electron of sulfur is going toward oxygen. 1 electron it has got from carbon, but at the same time 1 electron is going toward oxygen. So oxygen will carry negative charge, this oxygen as it is. No change here. So now on sulfur there is no negative charge, no net negative charge, because 1 electron it has got from carbon, but at the same time it has lost 1 electron toward oxygen. Now this oxygen will become negative, which will be satisfied by this Na positive, this one. Join it here. So you can check what is released. Na2SO3. Na2SO3. Please check in reaction. Na2SO3 was released. It will be like this. Phenol is generated. But the problem is, with phenol, NaOH particles are there. This NaOH is used. So I am cutting it. This phenol will react with another NaOH particle that I am going to use. Please keep in your mind that how many NaOH we have used. One we have used. Now, phenol is generated. In phenol, this hydrogen is acidic. And what conditions we are using? Basic condition. Everything is happening in melted sodium hydroxide, so NaOH is still there. We know this hydrogen is positive, this is negative, this is positive, this is negative. This is negative, this is negative, this is positive. So again, acid-base reaction will happen. Phenol also have some acidic behavior because the hydrogen is connected with highly electronegative oxygen. So that's why it is carrying a positive charge. So positive and OH negative, they will combine to release out H2O, and between oxygen and hydrogen bond will break. Electrons will transfer completely toward oxygen. So oxygen will become complete negative, which will be balanced by Na positive. So finally you will get ONA, sodium phenoxide, in which between oxygen and sodium there is a ionic bond. Oxygen is carrying complete negative charge, sodium is carrying complete positive charge, and what is released out? H2O. So you can check, we have used 2 NaOH particle total, 1 Na2SO3 sodium sulfide was released out, and 1 H2O particle is released out. Please compare it with balanced equation. So this was the third reaction. After this, ONA, we have to hydrolyze it. A very simple mechanism it have, the last mechanism of the reaction. This sodium phenoxide, in which oxygen have 3 lone pairs carrying a negative charge and a positive. We are going to hydrolyze it in the presence of dilute HCl. Dilute conditions means lot of water, excess of water. Excess of water will provide you H positive, OH negative. This H positive will attack on O negative, Na positive will attack on, and OH negative will attack on Na positive. So finally OH plus NaOH will generate. That NaOH is a base, this is acid. Again between them reaction will happen to create NaCl and H2O, and finally we will get phenol. So this was the mechanism of this whole reaction step by step. One more point, it was skipped from my mind. In third mechanism, that third mechanism which you have done, conversion of sodium benzene sulfonate to sodium phenoxide, it is also known as addition elimination mechanism. Addition elimination mechanism. Why? Because firstly you can check OH was added on this carbon. Am I right? First step, OH was added, and then secondly SO3Na was eliminated. So we are calling it addition elimination mechanism. That's it. This is the end of the video. This was the mechanism of this reaction. Now in next videos we will understand chemical properties of phenol. Thank you very much for watching the video.